Here are some more examples. If we have 7x plus 2 equals 51, the first thing I'd want to undo is this adding 2. I'll undo adding 2 by subtracting 2 from both sides. I'll get 7x over here and 49 over here. So 7x equals 49. I can finish this one up by dividing both sides by 7. So I get x equals 7. And of course I could check my work here. Probably a good idea to get into that habit. Rather than just plugging it into the computer and having it tell you if you're right or wrong, you really need to kind of be able to check these on your own. It adds a lot of confidence to actually do the numbers, and when there is a mistake, it kind of gives you a better idea of why there's a mistake. Alright, in this one we have 18 minus 5x equals 3. This may look like we're subtracting 18, but we're not subtracting 18. If I was to rewrite this as addition, as I have recommended several times already, you can see that we're actually adding 18. I would really want to think of this as multiplying by negative 5 and then add 18. So to undo the adding 18, I will subtract 18. So when I subtract 18 from this side, those cancel out. I'm changing it instead of subtracting 18 to adding a negative 18 just because I think it's probably a little easier to think about. 18 minus 3 is 15, except it's going to have to be negative because the 18 was negative. Alright, so we get negative 5x equals 15. Let's divide both sides by negative 5. We get x equals 3. Taking a negative divided by negative, which is a positive 3. Alright, let's check my work. 18 minus 5 times 3. Whenever you're checking your work, it's important to go back to the original version of the equation to minimize the chances that, if I had made a mistake somewhere along the line and I went back to after I had made the mistake, it wouldn't reveal that I had made a mistake because it would just reveal that this equation would be true. If I had, made a mistake between the first and the second, or the original and the first step here. So in any case, checking with the original equation, this gives us 18 minus 15 equals 3, and that's a true statement. On this one, we're dividing by 5, then subtracting 4, and the ultimate result here was 6. So to undo these, I'll add 4 to both sides first. X over 5 equals 10. Then I want to undo the division, undo dividing by 5 by multiplying both sides by 5. We get x equals 50. 11 minus x equals 2, just like the one that's directly above this. I would want to think of this as adding the opposite of x, or adding a negative 1x, if that helps. So we're taking x, we're changing its sign by multiplying by negative 1, then we're adding 11. If I want to undo these, I'll start by subtracting 11 from both sides to undo the addition. We get the opposite of x equals negative 9, or negative 1x equals negative 9. Then I'll divide both sides by negative 1 to get rid of that coefficient. We get x equals 9. And on this one, I have x's in multiple locations. And what we saw in the previous video, the best thing to do here is to combine like terms. 3x plus 1x equals 18. This gives me 4x equals 18. To get rid of the dividing, and to get rid of the multiplying by 4, I want to divide both sides by 4. I get x equals 18 over 4, but I can reduce that by dividing both the top and the bottom by 2. So I get 9 over 2. If I wanted to check that one, I'd probably plug in 4.5 into the calculator, since 9 divided by 2 is 4.5. But I think we've seen enough of those, so I'm going to just call it there.